All right. Hi, everyone. My name is Mikael. I am iOS developer here at Qapital, and I'm going to talk to you a little bit about reactive programming at Qapital. So we've been doing reactive programming since beginning of 2014, so a little bit more than 3 years now. And we thought we would share some of the patterns that have evolved here at Qapital and how we write our apps using Reactive. We're using Reactive Cocoa, but this could just as well be applied to RX Swift or some other reactive framework. So there's going to be a short introduction to reactive programming, just so everyone knows what it's about. And then we're going to write a small demo app just to show off these patterns. All right. First of all, what is reactive programming? There's a lot of definition out there on the internet if you search. I think a lot of them are very academic and they're kind of hard to grasp for beginners. But there's one page called Introduction to Reactive Programming, I think, which sums it up pretty good. And they say reactive programming is programming with asynchronous data streams. That's still pretty abstract, but the idea is that we model everything as streams of values. So a property on a class is a stream of value. The click of a button is a stream of values. Every time you click the button, you're going to get a value on the stream. Network call is also a stream of values. So you perform the network call, you get a stream object, and once that network call returns, you're going to get a value on the stream. These streams can then be observed, so we can listen to the events that come on them. We can combine streams, we can convert the values that come on the streams, we can convert values that come on the streams to other streams, like when I get a property update, I want to make a network call or something. All right, so how do we do this? There's a number of frameworks out there. I think the biggest family of frameworks is probably the reactive extensions ones, which has RX Swift, which is available for iOS. There's also Reactive Cocoa, and there are sub-projects like Reactive Swift, which is the one we're using. And that's mainly because that was the one that was around when we started. So these frameworks will provide the objects that we need to model these data streams. And they're going to provide the operators that we need to operate on them. So to combine them or filter them or map them or what we want to do. And we're also going to get ways to integrate these streams into the standard iOS frameworks like UIKit. So we can easily get the values on the streams into our views, for example. So, quick example. Let's say that we have two inputs on a class. Whenever one of those inputs change, we want to make a network call. Whenever that network call completes, we want to make another one. And then finally, we want to take the result and we want to set it on a property on the class. So basically, we're being triggered by two inputs, and the final result will be set on the result property. So simple block-based solution might look like this. We have our two inputs. Whenever one of them is set, we're going to make a request with those two variables. We have a result property. So make request takes two inputs, makes request 1. In the success block, it makes request 2. And then finally, it sets the result on self as a string. And then there's some error handling there. And now in a reactive version, it might look something like this. We've converted our two input properties to these mutable properties, which are basically wrappers around the properties that allow us to model these streams. We've also created our modified our result property to one of these mutable properties. We're then going to, in some kind of setup code, it could be init, it could be view.did_load or something. We want to say that everything that comes on the stream to the right of this operator, the small arrow there, we want to bind all those values into result. So what we're doing on the right side of the statement is basically we're saying, take the streams that come out of input 1 and input 2 and combine those into a tuple, basically, and send those on the stream that we get back from combine latest. We then want to convert those into another stream, basically the stream we get back from API request, So we're going to use that flat map operator. And then finally, when that stream passes a value, we want to once again convert it into another stream. So we use the flat map operator again. And then finally, we just want to map the value that comes back from API request 2 into a string. So we use the map operator there. And then basically, if any of these previous streams would send an error, we're going to end up in the flat map error there, and we're just going to set the string value. So I think this reads pretty nicely from top to bottom. We got rid of the nested blocks and everything. This is a pretty simple example, but imagine if input 1 and input 2 were actually 2 network calls. This code would look exactly the same. We wouldn't need any nested success blocks handling those 2 responses or synchronizing between them, or what happens if input 1 and input 2 are set right after each other, which of these which of the network calls would actually return last. We would need some kind of synchronization for that as well. There's another subtle change here, and that is that we actually got rid of the dependency on self in any of the blocks, which means that we basically can reuse all of this code somewhere else, if that is some common conversion code, and just bind it into another property somewhere else. So what is it we're actually doing? We're basically declaring how we should react to our inputs and how we want to transform those into what we see on screen. So let's say that we have a button press that's going to start a chain of reactions, basically, which is finally going to be bound into some view or some label. And that's basically what it all is. We're declaring these rules of how we should react to our inputs. All right, so we're going to write a small demo app, and for that, we're going to go through some wording or some objects. This is Reactive Cocoa terminology. I think RX Swift would work. They're fairly similar. We have something called signals and signal producers. They're basically these data streams that I was talking about. The slight difference is that the signal producer acts like a factory method to create these streams. Basically, when someone starts observing that stream, the signal producer, it's going to produce this data stream. That works well for network calls, for example, where we might not actually want to perform the network call until someone's interested in the result. We have properties, those mutable properties that I was showing. And the final one that we're going to touch is action, which is basically a way to model an asynchronous operation. And those could be bound to buttons. So these actions also handle like the enable state or executing state, so which will then also enable or disable the button, for example. We're also going to touch a little bit on view models at Qapital. So view models, I guess everyone has some kind of relation to them. They might mean slightly different things at different places. We see them as something that sits between the model objects and the views. So basically take a set of model objects and convert those into something that's applicable to be displayed on screen. And since we're using Reactive Cocoa here to bind values from our view model into our views, our view controllers are just going to act like a setup code, basically. We want as few dependencies on other view models as possible, basically for reuse. We want our view models to kind of like, they should be able to work in isolation, basically. And finally, we want as much of our business logic as possible in the view models, basically for testing. All right, so the demo app that we're going to write. It comes with a small companion Ruby server, which allows you to list a bunch of users. Each user has an image, a name, and a state. And the state's represented by that small checkbox. There's a button which allows you to toggle the state of a user. And when you do that, you're going to get this small alert, which asks you to confirm. So let's see if we can go to demo instead. And all right, I'm going to sit down now. Okay, so a quick look at the project. We have our view controller, which, sorry? Oh, of course, yes, sorry. Is that better? Even bigger, or? Bigger. Can I do this? No, I can't. Oh, that's of course better. Thank you. All right, so our view controller has some outlets to the table view, to the button. It has a view did low, which basically just creates our view model. Our view model has nothing, pretty much. So the first thing that we need to do is we need some way to tell our view model that it's supposed to load its data. And for that, we have something we call the active property. And the intention with that one is basically to tell the view model when it's being displayed or when it's being hidden. And then the view model can act accordingly. So if it's being displayed, maybe load the initial data or reload data. If it's being hidden and it has some long-going operation, then it could perhaps cancel that operation, like an upload or something. So, all right, and that's basically the property that we need. We also have this activatable protocol, which just says we should have an active property. All right, then we need to actually tell our view model that it is active. And we do that with our view controller. Basically, in view will appear, we're going to set the value to true, and if view did disappear, we're going to set it to false. All right, so our view model knows when it's active or not. Next thing would be to actually populate the table view. When it comes to table views and collection views, we don't want our view models to actually depend on or implement the table view data source or delegate or collection view protocols, because we want to be able to maybe reuse them in another scenario where they're supposed to display things in a collection view. So what we want is some kind of data structure, generic data structure that can model the sections and items, basically. So what we have is a list view model protocol, which is basically a two-dimensional array. And this array then has the sections on the outer array, and then its items, and the items correspond to what should be displayed in table view. Each item in itself is a view model. Now, we think this is, I mean, it's fairly easy to reason about. It's easy to debug. I mean, this two-dimensional array, you can easily see the values in them. And it's also important for us to actually get something that fits into the reactive model, right? So we're gonna trigger a reload with some input, in this case the active property. And we want to bind that into some output, in this case the property that the list view model protocols specify are the sections of the view model. So first thing is we want our item view models. So we have a user item view model, which is initialized with the user. We copy over the title and the enable state, and we say that the avatar image is basically provided by the API. So there's a download image method there, and that's going to return one of these signal producers. So nothing's actually going to get downloaded at this point. We're just going to say that here's basically a promise that will give you an image once you start observing it. And we also just want to handle our errors by setting a nil image. So that's why we have the flat map error there. All right, then we're going to say that our view model corresponds to the list view model protocol and updatable list view model protocol. So the list view model is for static table view, so that just defines as normal sections property. The updatable list view model defines a reactive property to supply those. So we're saying that we have our updatable sections, which is a reactive property that's going to provide an array of basic list view sections. We then have this mutable property, which we can actually bind values into. All right, and we're going to make our view controller set up its table view. So basic setup code, some styling. We set ourselves as the delegated data source, and then we start observing this updatable sections. And whenever we get a new value on it, we're going to reload the data of the table view. And we're also going to say that we are data sources and the delegate. All right, so at this point, we have an empty list of sections in our view model. So to populate that, oh, I need to actually do this as well. All right, so we want to populate this updatable sections property. And we do that with our setup sections function. Okay, so what we have is we have this reload trigger, which is basically saying when we become active, when the active property is set to true, we want to convert that into fetching the users. So at this point, we have a signal producer which returns a list of user objects. We then want to map that into a list which returns these basic list view sections. So we do that with a simple map and return that. And we want to say that if we get an error, we just want to ignore it at this point. So let's see if this actually works. If that's running. Of course not. We actually have to do something as well. Right. Okay, now we're actually getting something listed. All right, so we have this, we have our list, we can select these, the normal selection handling, but nothing's going to happen when we toggle. So we want as much logic as possible in our view model, right? So we need to somehow tell our view model that we have something selected. And for that, we will add another property. And we will set that in our all right, so we list the sections. The view model is now aware of what's the selected item. We then want to actually perform an action on this. When the button's tapped, we want to toggle the selection. And for that, we're going to use actions. Right, so here we say that we have an action which basically takes no input and will not produce an output, which goes well with a button, for example, since there's no actual input coming from that button. All right, so what do we have here? The action will handle our enabled state, right? If the button should be enabled or not. And that's what the top two values there are. So state basically says that we are dependent on our selected item, and we want to be enabled if that item is not nil. We then pass that in, and the action will handle that for us, basically being disabled or enabled appropriately. We also want to make sure that we reset our selection if our action continues or completes successfully. So we're saying that if our toggle action completes, sends a value, then we're going to bind that into, we're going to set our selected item to nil, basically resetting our selection and again disabling the action. And then we want to hook this up to our button. All right, so we're saying that the press of the button should be handled by the action, toggle action in the view model. And this Coco action class here is just a wrapper around an action to actually get it into the normal target action world of buttons in UIKit. So if we run this now, we can see that our button is disabled by default. If we select something, it's going to get enabled. And if we toggle the state, it's going to get disabled. But nothing's really updating in the table view, right? So what we actually have is we have more than one input to what should reload the table view. And that is that our action completes and finishes, because we need to refetch the list of users. So we are going to merge the input that is us becoming active with when the action completes. So we're basically saying if anything comes on, either did become active or something comes from the toggle action, then that's going to be sent on the same signal, basically merging them together. Yes. If you had some kind of WebSocket thing going on, yeah. So as you can see, the users were actually enabled or disabled, but now we actually get the table view reloaded as well. Okay, so final touch. We want to have that dialog displayed. The simplest solution would, of course, be to just do a normal button action, IB action in the view controller, and at that point show an alert saying, do you want to continue or not? Basically, if they say cancel, do nothing, otherwise continue. But that kind of defeats the purpose of the view model, where we actually want as much logic as possible. And showing that alert is kind of part of the action, right? It happens when you tap the button. So, our actions are modeled as signals. And the displaying an alert and waiting for the button in that alert to be pressed can also be modeled as a signal. It's an asynchronous operation, right? We're just waiting for that to happen. So we're going to make that a part of our action. And for that, we have what we call the view model delegate protocol. And that currently has one function, which is select from a list of options with a title and a body, and return a signal producer that will send the selected option when they select something. So in the standard app, we have our view controllers implement this protocol, but in a test, for example, we have some kind of test class where you can actually mock this data. So this can fairly easily be tested as well. All right, so we will drag out our updated action. This part is pretty much the same. And we need to, of course, pass that in as well. All right, so we're basically, instead of returning the user store call right away, we're saying first to ask our delegate to select from these cancel and continue actions. Once they've done that, we're going to get that option sent into our flat map here. And depending on if they chose to cancel or continue, we're either going to just return an empty signal, which will basically finish the whole action, or we're going to call the store method, actually calling the store to the server. All right, let's see. Okay, so we're getting that alert display. We can cancel or we can continue. And that's about it for the nice demo app of Reactive at Qapital. So basically what we covered is how we handle our view models reloading data, telling them when to reload or when to cancel with the active property. We also looked into a little bit about how we look at table views and the fact that we want them to be a part of the reactive world and not actually live in the data source and delegate world of UIKit. And then finally, how we handle actions and button taps in our app. And if you are interested at looking a little bit closer at the code, it's available on GitHub in our Qapital account. If you want to get a hold of me, I'm available at Mikael.Gransel@Qapital.com or in the Cocohead Slack channel as @Mikael.Gransel. Thank you.
So, do you have any questions, perhaps, for Mikael?
How's the experience when you grow? How's the experience when you grow and the whole thing gets bigger and bigger and bigger? Like, does this help you really to separate the different parts and make it very modular?
Yeah, I think so. I mean, it helps a lot when it comes to actually implementing the view model pattern, I guess, because you need that way to kind of shuffle data between the view model and the views, right? And you can easily do that with the bindings, basically that jiggly operator. I think it also, I mean, view models are a lot more easier to reuse than view controllers. So I think, and I also think that, so it's like what that introduction to reactive programming, if you look at that, it says that it's like promises on steroids. And that's kind of what it is. I mean, it's a nice promise library. And it gives you all that, but it's also a lot more, which basically allows you to integrate with UIKit and Foundation and everything.
All right.
You first.
A small question. You handle the view models and views. What's models? How do you handle the models? It's in core data, or I see you have the API shared user and stuff.
Okay, so in our actual app, we use a caching mechanism, and the files, we're not using core data, we're just serializing JSON data to disk, basically.
Okay, so the model change can react it to different views and different
yeah, so, right? I mean, we don't have a big data model per se that you can listen to. Everything kind of like talks to the API and we'll get one of these signal producers back. So that's what we have the active property for, to actually reload things when they're needed. Instead of having this big data model that you can observe and automatically get updated, you're observing the active property and fetching stuff from the data model when it's needed. Does that answer the question?
Yes, thanks.
Okay.
Yeah. Another small question is like in the view controller, I see you initiated the view model in the video load method. Actually, it's kind of coupled with a view model for the view controller. How do you usually do that? Or
yeah, I mean, we do have, it's pretty much one view model per view controller mapping at the moment.
Okay, so, but basically the view controller is coupled with the view model.
Yes, so. But I mean, it's easy to what do you say, compose view models of like smaller view models, so you can reuse code that way. But in general, There's one view model per view controller, yes.
I mean, if you want to test the view controller, probably if you want to initiate it with different view models and something. Or
We can't do that at the moment, no.
no, cool. Yeah, thanks.
Okay, so last question.
In the demo, you requested data from the API inside the view model, and is that like your common practice, or are you injecting the providers of the data somehow as a dependency injection? Because
Yes.
it's kind of hard to test it if it's statically coded in the view model.
No, we're passing it in as like with the view model delegate in the constructors. So that we don't have like static singletons or singletons that we use throughout.
All right, so if anybody has any other questions, I guess they'll be able to catch you in the break. Thank you, Mikael.
Thank you.